How are you folks doing? Nobody's saying anything. How are you folks doing? All right, that's a little better. You having fun? That's fantastic. General sessions yesterday were actually great. They really had me pumped up about our platform. And today I'm going to tell you all about the data access and XML sides of that platform. My name is Omri Gazitt. That's Omri Gazitt for you non-native Hebrew speakers in the crowd. And I'm sure there are like one or two of you out there. I'm the group program manager for web data. And many of you are asking yourselves, what the heck's a web data? Where do I get one? That sounds kind of cool. Well, web data is a team that we formed last year from the data access team and the XML team. We glommed these two things together and we formed one team. And why did we do that? We did that because we had this innate belief that data and XML were going to be intertwined in our new platform. In other words, that data was becoming more and more about the web, and that XML, the most interesting use of XML on the web, was about data. So that probably was the longest intro slide that you'll see this whole show, I believe. But we'll start with talking about the motivation behind the work that we've done in the new platform. Spend the next few slides doing that. The question that everybody seems to ask me when I tell them I work on ADO Plus is, okay, what is that? Is that a new data access technology? And I tell them, no, it's not actually new. It's the follow-on to ADO. People keep on asking me that. They say, you know, the biggest thing that frustrates us about Microsoft is not that you have bugs in ADO or MDAC or ADB. We do have those. But all in all, they're pretty good. They're pretty mature. And we have a reputation, actually more than a reputation, of releasing a new data access technology once every 18 months or so with a new version of Visual Studio. You all know the acronyms: ADO, ODBC, RDO, OLADB, ADO. So one of the goals of this presentation is actually show you that we haven't screwed you again. Yeah! That in fact, ADO Plus deserves its name. It's not XDO or YDO or ZDO. It's really ADO Plus. So, in order to answer that question about why we even had to do anything to ADO, you have to start considering what the internet has done to our world. Now that bullet, the internet has changed everything. That's going to be on every slide that you see on every presentation for the last 5 years and for the next 5 years, right? But for me, the biggest difference that I see in application development against data sources is that we have a lot more loosely coupled applications that are being authored today. And XML is emerging as Bill Gates likes to say, the lingua franca of the web, but really the universal data format for serializing, for shipping data across the web. And that's pretty heavy stuff. Problems that we see face developers because of this shift that has happened is probably first and foremost the fragmentation of the programming models that you have to deal with. On the one hand, you have the connected programming model that you know and love from the old client-server days. You have a client that has an open connection to a database, and you do very tightly coupled operations against that database. OLADB and ADO definitely have their roots in that mode of programming. On the other side, you have the disconnected programming model that the web pioneered. HTTP is a request-response type of protocol. You don't typically hold any state open between interactions. Now, this new programming model, the disconnected programming model, brings about some challenges, the key of which is that handling state between these interactions is actually pretty challenging. When we came out with Windows DNA, everybody's probably read the book or has heard the mantra that you want to really program stateless applications. And customers come to us and say, what does that mean? We have state that we need access, that we need to have available to us between interactions. This is any but the most simple applications require state, and that's most prevalent in database applications. Well, handling state is very challenging, and we don't really actually tell you, don't use state at all. We rather tell you, minimize the amount of state that you actually have to keep open between network interactions. That's the key, and that's actually not all that easy to master. Finally, just when we thought that catering to the row and column model, the relational model, was safe, in comes XML and kind of revives that whole hierarchical thing, right? Just when we put those IMS books off on the shelf and, kind of threw them away, all our world kind of comes back, all that world comes back to haunt us. Any IMS developers in the crowd? Wow, there are a few, man. Give those guys their canes. I age myself. I talk about IMS. Gosh. So let's talk about the state of the union today. What we have in terms of data access and XML support in the WinDNA platform. MDAC in Windows 2000 is definitely based on a two-tier model. The two-tier development model was prevalent at the time that we designed MDAC. We extended it to three-tier by adding a component called RDS, Remote Data Services. And by and large, that feels like an addition. It feels like one of those things that's kind of an adjunct rather than a core part of the whole model. We also have fairly limited XML support in ADO today. We can persist record sets, disconnected record sets, down to XML, and read those back up. But we don't really support any XML that comes in. And finally, again, there's a dichotomy between the connected and the disconnected programming models. We've actually taken these two things and we lump them together in one object, the record set. When we talk to users, they tell us a lot, listen, we don't want to learn new things. Just give us a simple metaphor for programming applications. Don't give us different objects where we don't need them. But in this case, we actually found out that having one object for everybody was kind of confusing. The number one support call that we get on ADO and OLADB, well, really on ADO, I should say, is, I do an rs.open. What kind of flags do I pass? Is it a server cursor, client cursor? Is it a static or a dynamic? What kind of lock type do I pass? How many people know what I'm talking about here? Not many. Wow, you guys are masters of ADO programming. That's great. But the fact remains that most developers that I talk to admit to me at the very end that they actually just plug in values for those things. Okay, let's see. Does this work? No. Okay, well, that broke that. Oh, that setting works. Cool. Let me write it down for future reference. So one of the things that we were thinking about was exactly that maybe over-normalization that we did, if you will. Secondly, MSXML in Windows 2000 is, again, a very good component. People tell us they like it a lot. some of the things that they hit with that component is the fact that it makes no discrimination whether or not you have totally structured data, maybe data that comes out of a database, or totally unstructured data, like, some random markup file, like a Word document that I managed to mark things bold and things italic. The programming model is the same. It's the DOM, the document object model. And people tell us, that's kind of funny. I want to program against XML, but the DOM is kind of funky for that. It's like a tree, and what I really have is, a very well-structured hierarchy. The other thing that people told us is that the integration with a database is not very easy with XML. Of course, we've addressed that in a great leap forward in SQL Server 2000. SQL Server 2000 returns XML natively. There's a great talk later on in the show by Rich Roman to tell you all about that. But the fact is that the MS XML we ship in Win2K has that problem. And finally, there's really no stream-level support in the XML stack that we ship. And what I mean by that is, on the one hand, you have this DOM that does support loading data asynchronously, but you really, in order to fully access all that data and edit it, you have to wait until the whole thing is materialized in memory. And that is not very suitable for some certain classes of applications. For example, if I have a message processing kind of scenario, I'm just going to pull out the header and I'm going to go, is this message something I want to look at? Nah, throw it away. Or, oh, that's a message I really am interested in, let's process it. I don't really want to read that whole XML file just to know that one piece of information. Do you guys know what I'm talking about? That's what SACS was invented for, and we don't have support for SACS in the current stack. Again, we are addressing that, but that is a problem that we hear, and that is one of the guiding principles that we used in designing this stuff. And finally, there's not too much integration between those two things, MSXML and MDAC. People tell us we love the very mature set of functionality that we ship in MDAC. And we really, really want to XML enable our application. We love XML. But these two things are kind of monolithic. It's not very easy to write applications that really cross these two things. That's another thing that kind of made us go, So here's the opportunity. None of these problems will actually cause us to say, okay, well, let's think things over here. We are addressing every one of these problems in our existing set of core technologies, MDAC and MSXML. But in comes the .NET framework, the .NET platform, about 2 years ago or so. And it caused us to think a little bit about this. What kind of XML and data access support do we want to put in that platform? Right at the very beginning, we realized the key to creating a great framework for data access and XML is to really be a core part of that thing, to feel like it, to use the same design patterns, to use the same type system. And so we realized we might have to have something a little new here. So the result is the data and XML frameworks that we are shipping in the new platform. Now, the first and foremost point, and these are probably the 5 points that, if you have anything you get out of this presentation, I want you to get these 5 points. So everybody over there in the back, you better wake up now. Number one, this is a natural evolution of ADO and MSXML. We listen to our customers, and then we go redesign stuff. No, we listen to our customers, and they tell us, we really like what you have today. We want this to be as familiar to the ADO programmer as it can possibly be. Second thing is what we call N-tier from the ground up. And really what that means is great disconnected support as well as connected support inside the ADO stack inside the ADO Plus framework. The third thing is XML pervades everything that we've done with data access and, of course, the XML frameworks. The fourth thing is that the architecture is actually unified. We don't have this XML architecture here and data access architecture here. We have one all-encompassing architecture that these pieces are really parts of. That's really why this talk is all about ADO Plus and XML together. And finally, again, this thing is very .NET centric. It feels like a part of the .NET framework. We kind of play that tightrope between keeping it looking like ADO and actually giving you objects that feel like part of that gestalt, that platform that Anders Heilsberg was referring to in the last general session. The next couple of minutes, I'm going to spend time introducing you to ADO Plus. ADO Plus is a functional superset of ADO 2.6. The big exception is server cursors. That's one of those things that we might introduce in the next beta or so. But I actually want to ask a question here. Does anybody use server cursors? Any show of hands? No, show of hands isn't going to show up. Really? Clap, 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 clap. Oh, a few server cursor users. Okay, I feel for you. No, seriously. Send me an email at omrig@microsoft.com because we actually use customer input a lot in trying to figure out what we're going to do for the next beta. Today, if you want to take that CD and install it, and you want to write very tightly connected code that does positioned row updates, you still have to use ADO. We're definitely looking at putting an object to kind of complete the picture there. ADO Plus also contains the managed equivalent of the old ADB layer. What that really means is, no, we didn't actually go off and take that big honkin' old ADB spec and say, okay, function by function, we're going to make this thing managed. No, what we actually did is say, there's that dichotomy between old ADB and ADO today. It's this COM automation dichotomy that, is bitten a lot of people in the butt. You want to program to something from VB, it has to expose iDispatch. It has to be a COM automation layer. If you're a C++ programmer, you typically go to the metal. That's one of the key things that we actually fixed in this new .NET framework in general. Every language can access any type of object, any type of facility inside of the system, regardless of what language that thing was coded in. There's no real dichotomy. There's no real privileged languages and unprivileged languages. And so ADO Plus really has both that low-level, stream-level support that OLADB is really good for writing very fast applications. And it has all the high-level services that you would normally associate with ADO. And finally, there's an explicit division between the programming models, between the connected and disconnected programming models. There's managed providers on the one hand for connected access, and on the other hand, there's the data set object for disconnected access. So in other words, we took that record set and we pried out of it that forward-only cursor and said, that's connected. We pried out of it the cursor engine, the client-side cursors, and we said, that's disconnected. Let's actually make those first-class objects. And I'll talk about those things in the next coming slides. First, managed providers. You'll see that the object model is very similar to today's ADO at the connection command level. And if you don't take my word for it, go see Mike Pizzo and Tom Kaiser right after this talk. They'll actually prove it to you. They actually have code from a different PDC that shows you how to use ADO. And they look at that and they show you right against it how to use ADO Plus. And you know what? Code looks the same. man, I got to get you guys into it. I'm making a deal with you. For every time you guys clap, I have to drink beer tonight. Uh-oh. Okay, for every 5 times you clap. Next we have, what's that train of thought? Where'd it go? Okay, all right. Next we have efficient stream level support for result set processing in that new object I call data reader. That thing is the equivalent of a forward-only record set. You can always program against it knowing that it gives you the same level of functionality. Whereas today, you never quite know what your record set that you got past is supporting. You have to query a bunch of flags. You have to see if this is really editable. If you maybe don't do that and you call move previous or move first on it, whoops. This thing is only good at one thing. It's great at shoveling data out to you. Here. There's the next record. There's the next record. Doesn't know how to scroll. Doesn't know anything about updatability. It's the fastest way to get data out of a database. And it's really quite fast. We've done benchmarks, and it's definitely faster than what we have today in ADO. That's 2 beers. And finally, we have a new object that bridges disconnected and connected programming models, or layers, the dataset command. Now, I haven't really introduced the dataset yet. All you have to know at this point is that the dataset is the object that epitomizes the disconnected programming model. In other words, I modified the order of these slides and I forgot to actually do something about it. But the dataset command is the thing that knows how to fill a dataset from a managed provider, and it knows how to take diffs back out of the dataset in a disconnected fashion and push them back to the database. Finally, we have 2 implementations of these puppies. We have a SQL implementation and what we call the ADO managed provider. Let's start with the second one first. The ADO managed provider, as we call it, is basically your gateway to all of those OLADB data sources out there. It goes and talks directly to the OLADB layer. We call it the ADO managed provider because the object model looks a lot like ADO. But it really is built on top of that OLADB layer. And it knows how to get data from all OLADB data sources. So all of your investment is perfectly preserved. SQL managed provider is an optimized guide that knows how to suck data straight off of the wire, token by token. The wire format we call TDS, which is the SQL Server wire format, and expose it into the managed world in as quick as efficient way as possible. Basically circumventing all the OLADB and ADO layers. And that's actually quite fast. We've done throughput analyses. We haven't even perf optimized this stuff yet. And I already see a 3-to-1 throughput difference between the SQL managed provider and the ADO managed provider. So we realize that some of the database vendors might want to write their own. And so we'll provide an SDK for doing that. And one of the coolest things about this is that this is not the OLADB spec. This is the very thin managed provider spec. This thing is not supposed to be a replacement for OLADB. We've done that thing, been there, done that, wrote the book. Really, wrote the book. But the fact is that there are performance gains to be had. And so we do realize that it is appropriate for people to write their own managed providers. If Oracle, is Oracle in the crowd? Is IBM in the crowd? Oh, we love you guys, man. Come see me after class and we can talk about that some more. But don't go through my trash now. God, how many times are we going to hear that joke, like, through this entire conference? Definitely not the last one. We know how to get mileage out of that one. Let's talk about data set. A data set can best be thought of as a disconnected buffer of tables. But the cool thing is, there is no knowledge of the data source. Once you get the data into the data set, it doesn't know where it came from. Could have come from a user directly manipulating it from the front end. Or could have come from a database. Or it could have come from an XML file. We don't know, we don't care. And that's inherently what makes this remotable. You can take that thing, serialize it down to XML, deserialize it back, remote it between tiers. And that is basically the disconnected rec set on steroids. It also gives you some local sort and filter operations the same way the cursor engine gave you in ADOCE. And that's kind of cool too. Now, the key difference between the data set and just record sets is that the data set actually is a more rich programming model. You don't have to do the move first, move next, move next, move next, move last. That's not how you typically would actually program against tables inside of the data set. You could actually index into that thing either based on an ordinal or based on a primary key of table. So you could actually say, table sub 0 dot column sub 1 and give it a primary key and it'll go find the row for you. So the kind of rich operations that you can do against the client cursor are actually exposed in the programming model. Yeah. Now the other thing that this guy is good at is it remembers the relational model that is stored inside of it. So these are not just tables that are unrelated. You can actually say, okay, that customer table that I have is related to that orders table by a primary foreign key relationship. And when I wrote that thing, when I wrote the data set, all of the data model inherent in the data set is remoted with it. All right. It has great XML support. It knows how to save XML and load XML natively. That's its native serialization format. It also knows how to load an XML file. And the way it loads an XML file is it has an existing schema, and it goes off and shreds that XML into tables. It says, okay, in my schema I know that I have a customer and an order. And I see some customer tags, and I'm going to map those into that customer table. I see some order tags, and I map those into the order tables. So you can actually program against your XML data relationally when it is relational data. Now that's cool. In addition, if you actually don't know the format, the schema of the XML file at design time, the data set also knows how to infer schema from the XML, and it does that dynamically. That makes for really, really cool demos, but it actually is really nice to start developing your application. You have an XML file that you're getting from a business partner. You just suck that into the data set, makes rows and columns for you, makes tables. You tweak that model, then you tweak the mappings a little, and there you go. And finally, Visual Studio.NET adds a really cool feature. It knows how to generate classes from schema at design time. And that gives you strongly typed access to data. Lots of people have been telling us over the years, I know the schema of my data ahead of time. But you make us go through a very late bound kind of programming model in order to access that data. I really want to access data as customer.name, customer.address. Not really, as row, open parens, in double quotes name, .value or something. And so, this programming model lets you access specific elements, specific columns, instead of data set dot table sub 0 dot column sub 1, rather as data set dot customers, where customers points to the table inside of the data set, Give it a primary key of John, takes me to that row, dot address. So I can write these paths expressions straight through my relational data structures. Yeah! It really helped to reduce that impedance mismatch between relational databases and between object-oriented programming models. People tell us that 60–70% of the code they write is in that OR mapping. So this is the first step towards getting you to the point where you don't have to worry about that stuff. So to sum up the ADO Plus architecture, you have the Visual Studio designers that lets you lay out controls on web forms or Win forms. And then you have the .NET class generator that knows how to take a schema and generate strongly typed data sets, which are nothing other than subclasses of the data set class itself. Now, we actually have a public object model that you can kind of wire to that generation facility yourself. But of course, VS.NET makes that really easy. Once you've got that data set, let's figure out how to populate it. You can either populate it using XML. The XML can come in either through a string or a stream, in through an XML text reader, or an XML node reader, and I'll talk about those things when I talk about XML. But already you can see that XML is really an intrinsic part of what we do in data access. And finally, I can also push data into the data set using a managed provider and that data set command object that I talked about earlier. Just to recap some of the benefits that you get with ADO Plus. First, you have a much improved disconnected story. The data set is a first-class object. It's a rich object that lets you program against your local cache of data in a very rich way. You have great XML support in the data set. The data set knows how to directly load XML off of a string or a stream. Its native serialization format is XML, so it's very remotable. It's just like a disconnected record set, except it's on steroids. You have language-neutral data access, so no more of that ADO-OLE-B dichotomy. You got only one thing. Yeah. You got great design time integration with Visual Studio. And we've done some work in the past to integrate the data access stuff with Visual Studio, but this time we've really done a great job. We really give you the ability to do what we call schema-specific as well as ad hoc data access. Again, can't stress it enough, core part of the .NET framework, but still retains that ADO familiar look and feel. Deep cleansing breath, as Don Box says. How many of you, by the way, went to see Don Box's talk? Anybody? Well, there are like 2,000 people in this room, and there were 2,000 people in Don Box's talk. I figured there would be like a good crossover. How many people went to see Don Box's talk? There you go. He's awesome. I love Don. But I have to beat him up a little bit about that XLT thing. XSLT can let you convert from one schema to another easily. All right, yeah. I'll have to tell Don that it worked. So Don and I actually had kind of a little verbal sparring over that. And we actually agree that XSLT is a good tool for doing very simple transformations. But XSLT is actually not a good programming language. But when you actually get to nitty-gritty types of transformations, you definitely want to start using a real programming language. Now that we have that out of the way, I can say the word bullshit now in my talk because Don Box said it. The XML framework. This is the functional equivalent of what we give you in MSXML 2.6. And by the time we ship this puppy, VisualStudio.net, we will have, of course, already shipped MSXML 3.0. Our support will be the same in the .NET release of Visual Studio. In other words, the standards that we support in MSXML will have full standard support of the same standards in the XML framework. The philosophy for the XML components is, first and foremost, we want great standard support. We love XML. People ask me, why do you love XML? I don't know, are there any marketing people that are about to take me off the stage or something? Because I'm going to tell you something. Not sure they're going to like this. But the bottom line is, we love XML because we love selling Windows servers. Yeah! Here, I said it. But you know what? We've also realized, finally, that our customers have lots and lots of disparate, different architectures, disparate infrastructures, different environments. And you know what? They're going to throw them out anytime soon. They're going to have mainframes, they're going to have Unix boxes. We got to deal with that, you know? And the one way we actually help them buy more Windows servers is we help them integrate those Windows servers with all those other environments. XML is just fantastic for that. So our whole strategy on standards is exactly as follows. We go to the working groups. We contribute actively. We want to drive those working groups sometimes in ways that seem important to us. But we actually, at the end of the day, agree on the protocols. We want to interoperate with everything else. That's true with TCP/IP, it's true with HTTP, true with HTML, DHTML, and it's of course true with XML. The place where we can actually add value, the place where we put all of our innovation, is in the programming model. We're actually good at that. We're good at developing APIs that people like to use, right? Yeah. People use ADO all over the place. People like ADO. We're good at designing APIs. So that's where we're putting all of our innovation and giving you a better experience in accessing XML. And I'll talk a little bit about that later. We also have a very chainable architecture, a very pluggable architecture. And finally, again, we're a core part of the .NET framework. See what we're supporting as far as standards. I said, as far as the programming models, we feel like we can do some innovation. But at the same time, there are standard programming models out there, like the DOM. Of course we support the DOM. We like the DOM. We don't love the DOM like we love our own objects, but we like DOM. It's kind of cool. It's great for actually writing programs against data that looks like a tree. So the DOM is exposed as the XML document class in the programming model. Now, Chris Lovett, who's probably our #1 XML expert at Microsoft, is going to do a talk that delves deeply into all of the objects in the XML programming model. I'll just give you a brief overview, just like I did for ADO+. You would definitely want to check out his talk on Friday to get the nitty-gritties. And of course, I'm going to demo some of this stuff at the very end, too. Show you how cool it is. For validation, which is a very important service you do as a parser, we support DTDs and XDR. XDR is our own schema format that we released before there was any schema format at all floating around. So we still, of course, need to support that. That's what SQL Server 2000 emits today. That's what BizTalk uses today. But we are totally, totally committed to going to XSD. And while we're always going to have to support XDR, XSD is totally the strategic schema format for us. We'll have validation for it in a future beta. For XSLT and XPath, we have quite a little bit of support in the box already. And we're going to complete it again in another beta. So you can already play around with it. There's a lot of transformations that you can actually do. SAX, which is a stream model API, it's a push model stream level API, we ship as a sample. SAX is not really a W3C standard, but a lot of people use it out in the marketplace. It's the only thing today to use if you want to use, if you have a streaming scenario. And finally, there's other standards that, of course, we're tracking. This is where the innovation is. These are the brand new objects that we've created in the XML framework to help you better interact with XML in your programs. The XML reader is a pull model stream level parser. It gives you token by token by token all the XML that you're processing over. We actually think that this pull model is easier for developers to initially use. A push parser, just like Don Box said, involves building that hairy thing you call a state machine. And some of you developers in the crowd are all over that. Some of you developers in the crowd don't really care about writing state machines. You just want to pull out some tokens off of a stream. This is by far the fastest way to access XML. The XML reader is actually an abstract class. We have concrete implementations. We have 2 that we ship, actually 3 that we ship in the box. And the 2 that I'm talking about right now are one on top of a stream or a string, and one on top of a document. That is, if I have a document that I've already materialized in memory, in the DOM, I can access that thing in the same way that I can access a stream today. That gives me a basic independence of where the data came from. A very chainable architecture. The validation is actually done using what we call a delegate in .NET framework speak, which is really a callback. So every time I see a token that doesn't look like something that I recognize in my schema, I send you back a callback and say, oh, that thing is not valid. XML writer is a well-formed writer. Today, when people try to emit XML onto a string or a file or a stream, they typically use sprintf or stircat. That's the state of the art today. We actually feel like we can give you a lot more services in order to format out XML. And that's exactly what this XML writer is. It takes care of a bunch of little hairy details for you, like creating well-formed documents with the right type of header information, with the right type of entity, type of handling, etc. Third up is the XML Navigator. And this is a lens-oriented object model on top of an existing document. Now, what is this lens thing, you ask me? It's kind of a little like a record set, except that it knows how to go up and down in the tree. It knows how to navigate a bunch of different axes. And in fact, the way I tell this guy where to go is that I give it an XPath expression. I say, here's your axis. Go to the next child and look for something that's called Charlie, and give me the and go to that node. So this is where we implement XPath support. It's also a potential perf win, because the data doesn't all have to be in nodes. When the data is highly structured, we actually optimize the storage underneath covers, and we store things in more contiguous data structures. The XML Navigator is a lens that can give me methods to get properties off the current node, if you will, that I'm looking at, without actually materializing that node as an object. And anybody who's programmed in a garbage collected system before will tell you that when you create too many objects, it kind of hurts your scalability a little bit. So this is a perf win in many scenarios. Finally, my favorite object in this whole model, the data set's pretty cool too, but my favorite object is XML data document, which I call a data-friendly DOM. And I'll demo to you in a couple minutes. So here is how the XML architecture all kind of shakes out. I love this picture too. So you have XML that comes either through a string or a stream that you can read through the XML text reader. This diagram should look pretty familiar from the dataset slide. You can also read XML through the XML node reader. Both of these things come up to an XML reader abstract class. I can read from that reader, token by token, or I can shove all that data into an XML document. Now, I can use the writer standalone also. I can use the XML text writer to just write out to a string or a stream, or the node writer to write out to another document. But I can also save data out of the document into a writer. So this whole architecture kind of loops on itself and is very chainable. I can chain an XML reader to an XML reader to an XML reader, implementing in each one of these some kind of specific functionality. Our dev manager, William Adams, is going to demo on Friday a little filter that you can write that's just implementing an XML reader interface. And I can read out of that filter, and that filter can hook up to any other XML reader, and that could be our actual parser, and implement filtering functionality on top of that stream in a very chainable manner. This is good stuff. XSLT. Bullshit. XSLT is actually a pretty cool little beast. A lot of people are going to use XSLT to do very simple transformations. And BizTalk actually embeds an XSLT engine, the MSML engine, in order to do transformations, simple transformations, between one schema format and another. Our managed XSLT engine, .NET Framework XSLT engine, binds to that XML navigator that I told you about just a couple of slides ago. So you can actually plug any XML navigator implementation underneath, and you get XSLT for free. We've actually written some demo XML navigator implementations, and as it turns out, you can do XSLT on top of those. We built one on top of, say, the file system, and we do these transformations on top of the file system. It's really cool. We have two built-in implementations that we ship in the box. One's called a document navigator that iterates over an XML document, and the other one is a data document navigator that sits on top of the XML data document, my favorite object in the system. I'm going to drink a beer for every time I say that, too. So XSLT is actually really cool. It produces either an XML reader that you can suck the tokens out of, one by one, so you can actually drive the transformation through the reader. That's really cool. Or you can actually produce an XML writer, or you can give it, I should say, an XML writer. Let me show you how this works. You have the XSL transform object. You give it a navigator. This one's sitting on top of an XML document. You give it an XSL transform. It gives you back a reader that you can read data out of. Or you can pass it an XML writer, and it'll write to that thing. And that's more or less similar to the support we have today in MSXML 2.6, where you actually always write to that stream. Finally, my favorite section of this talk, data and XML together. Again, we've realized early on that data is XML is data. These things are very interrelated. My favorite object, the XML data document, unifies XML and data. On the one hand, it plugs into the entire stack that I showed you of XML services, XSLT, XPath, and the like, because it's a subclass of the XML document. It's a DOM. You can program against it like a DOM. At the same time, it's different from the data set, which is also a programming model on top of XML, because it retains the fidelity of all the incoming XML. What I mean by that is it retains all the tree structure of that XML, whereas dataset shreds all of that data into tables. On the other side, it plugs into the entire stack of data services. And here's the real innovation. You can get a dataset view on top of a subset of that data in the XML document that looks relational to you. I'll demo that. That's really cool. And finally, these two views really stay in sync. So here's that unified architecture. I have the XML stack on one side, I have the data stack on the other, and I have the XML data document that keeps these things in sync and really makes that one unified architecture. So here are the scenarios again, the benefits that this enables. You can simultaneously expose data as either a relational structure or as XML. It's great for semi-structured data. I'm going to show that in my demo. I have a purchase order that comes in. Some of it I want to keep as XML data. Some of it I want to map relationally. And what that really gives me is the ability to put separate tools on top of these different views. A tree control to bind to that XML view. A grid can bind to that relational view. So I can use the natural object model for each of these subsets. And finally, just to address that monolithicness of previous architecture that we had, both the DOM and the dataset can what we call grow up. You can program against the XML document, and at some point you might realize that you do have a subset of the data that looks relational, that you want to tap into all those data services. You can just change one line of code, just instantiate it as an XML data document, and all of a sudden you can get a data set out of it and expose it out to all that data stack. That's cool! On the other hand, I can start from the data set, and if all of a sudden I realize, you know what? Like, I had all relational data, but right now I actually have a document that's evolved beyond that, and I want to keep some of those annotations, I can actually get an XML data document and just use that data set view as the thing that I've programmed against before. So I don't have to throw out any of my code. Both of these avenues can grow up. And we actually think that's pretty fundamental. So finally, we get to the demo. Yeah! This is a website for order processing that I've created. It's kind of a simple, very simple little type of thing that I kind of completed on the plane on the way over here. It's very easy to write this. I created a web form in Emacs. Unfortunately, not in Visual Studio. I'm kind of an Emacs head. But of course, you can do this in Visual Studio a lot easier. And it has one bound control, a data grid, for displaying the order items, which is the relational portion of the document. I read purchase order into the data document. I map those order items into the data set. I modify that data using the data grid. And finally, I transform that original document with the changes that I made using XSL. Bullshit. And spit out another document. I think I've cured you from the XSLT problem that Don introduced. I don't hear that anymore. Oops. All right. So let's look at the demo. So what I did was, in order to make this semi-real, real life, real world, I don't actually write purchase order schemas for a living, but there's a place where I can get one of those, a demo actually, pretty easily on biztalk.org. So I pulled out a schema from schemas.biztalk.org. You can actually click on that link, the PDC CD that you're going to get, and you can actually see which schema I used. I didn't cheat here. And I pulled out two things out of that thing. I pulled out a purchase order sample document and the actual schema in XDRs. BizTalk is still very XDR oriented. I actually ran that schema also through an XSD processor, something that takes XDR out and pushes out XSD. You know what? That's actually an XSL transform that did that. I'll have you know. Written by, yeah! Written by our whiz-bang XSL guy, Jonathan Marsh. And so this entire demo works against XSD schemas also. Just to show you guys how serious we are about this thing. In the code, you can uncomment the XDR section, or, sorry, comment out the XDR section, uncomment the XSD, and it all works. So this is what the purchase order looks like in raw XML. I think it's somewhere here. Here it is. Very simple document. Got a BizTalk header right over here with a bunch of stuff that I don't actually really care about. They're very interesting and important for me to push that document to the next stage of the order processing pipeline. But I actually, in my website that's used by this order entry person to verify that order, I don't really care about that. So I'm going to collapse this header here. This is the body. This is what's important. So I have a purchase order tag with a bunch of little stuff underneath it. I have a header. I have a contact element with some contact information. I have a ship to and bill to address. And finally, I have some purchase order lines with some line items. I've actually modified this document slightly. I've added more line items just to make this interesting. Here's a pretty version using an XSL transform, rendered using an XSL transform that I wrote on the plane. Took 3 hours. So, as you can see, this thing can be pretty printed, and the header information can come out like so, and the contact information looks like that, and here are line items. And I can already see what the target, what the thing that looks most relational to me is. It's that whole list of line items. That thing, why? Wouldn't it be cool to program against that relationally instead of using the DOM? Yeah, that's the answer. Okay. Let's look at the XDR schema real quick. I'll actually show you this XSD schema just for fun. So I have element again that's called purchase order. Has a bunch of sub-elements, PO header, contact, ship to, bill to, lines. I hope everybody can see this. I made the font as big as I can. If you can't, move closer. And I have for every one of these elements, I have some attributes. So I have contact, I have PO ship to, bill to. Lines contains an item element, or a sequence, I should say, of item elements. And then, of course, the items themselves. And finally, just for fun, I'm going to show you the pretty version. Again, Jonathan Marsh wrote this really cool whiz-bang schema, XDR schema, style sheet. Take that, Don. That lets you browse all of the elements in that schema. It just sucks in an XDR file and lets you navigate to the purchase order. The purchase order has all these things. So look at the lines. The lines have items. Cool. So by now you should be familiar with the document structure. Now let me go over here and go to my map tables demo. I actually think over here. So what I did was, I read in that po.xml document that I showed you. Now I'm displaying all of the tables that I got out of that XDR schema. What the dataset did underneath the covers was say, okay, let me look at that schema. Every element that I see, every type declaration, I'm going to make a table for. So I have a PO table for my top level purchase order element. Now, as it turns out, I need a way to link that top level element with all the stuff that's underneath it. So I'm going to give it one column. That PO thing didn't have really anything in it, but I'm going to give it one column, primary key, called PO ID. you have PO header, contact, and ship to and bill to, all the stuff that you saw before, and it has a column for every one of those attributes. And there's a special column at the very end of each of these called POID. I hope you guys can see that. That's the foreign key column back to that primary key, PO. That's how we link all this stuff together. And finally, the stuff that's really interesting to look at is the order item table. And again, I see, all the rest of this stuff I can program against using DOM. I don't really need a relational programming model. But if I have 15 of these order items, I really want to start looking at them relationally. So let's look at the source code that was used to generate this ASP Plus web page. First, let's look at this file, this ASPX file. It's a form, and it has that run as server attribute. I don't know if you guys have seen any ASP Plus talks yet. ASP Plus is awesome. It's really cool. You can actually write very rich applications that project out to anything from DHTML to HTML3.2. They give you those built-in controls, like data grid, that know how to do that automatically. So I don't have to write any of that in my application. And really, the interesting part here is this ASP panel thing that lets me add to it dynamically all these tables that you saw. So the form is just super easy here. And here's the source file itself. This is written in C#. The interesting thing to look at here is this function here that instantiates an XML text reader on top of this purchase order XML file, creates an XML data document, loads up data set mappings from this XDR schema that I have, loads up the document, and now gets the data set view of that. Now here I'm actually programming against the data set itself. The data set has a tables collection. And that tables collection has a count, a number of tables in it. So I can display the number of tables, which in this case was 7. And I can iterate over these tables, creating new label controls, setting that label text to the table name of that particular table. And again, creating a grid for every one of these tables, setting the data source for the grid to this data binder object we call data view. And all I have to do at the end, after I add these controls, is do this data bind step, and that goes off and renders the page. Pretty easy stuff. So now, I actually really want to show you the real part of the demo. That was just for fun, to show you how all of that schema gets mapped. This is the real heart of the demo here. I actually decided to create an editable grid. I can do that very easily by just adding some attributes on top of that data grid declaration inside of the ASPX page. And I can edit this. This thing supports editability inside of the box. The code just natively supports that. And I can edit some of these values. I'm going to cancel for now and show you some of the source real quick first. So here's the ASP page. All I have now that's of interest really here is a data grid control. But this time I laid it out on a page instead of creating it programmatically. And it has some event handlers here. On edit command, call my data grid underscore edit, which is in my C# file. Cancel, call the appropriate event handler, etc. And I put a button at the bottom of the page called transform that knows how to invoke this server-side code. On server click equals submit click. And again, that's executed inside of the C# file. That's the code as far as the ASPX file. Now, in terms of the actual C# code, Here's what some of that looks like. First, I have a global.asax file. And for those familiar with ASP, that's the equivalent of global.asa. I have an application start event that gets fired when I start the application. Now you have to remember that this thing, all these ASPX applications are very stateless. So if I want to store anything in session state or application state, I really have to write this global.asax file and store it there. So this code should look very familiar already. This is the same code I used in the first example, but this time I store in the application state, under document, I store this XML data document reference. And all of the details for handling that state are hidden from me by the ASP runtime. It's really cool. Now, there is a little bit more code here. Some of this code is not very interesting. So, for example, when I put my grid in edit mode, I want to set the edit item index to the item index that I clicked on. Here's the really interesting code. I get the XML document out of the application state variable. I get the dataset property out of that. Let me scroll over that you can see it. Cast that back to dataset. I eventually find the row that corresponded to where the user clicked edit. Then I start editing that. That's kind of like begin trans in database lingo. I want to suspend all of my referential integrity until I finish that editing. I get the column value out of the grid, out of the text box that's on that grid, and I set that column value inside that data set, inside of that row. I finish the edits. That's kind of like accept changes is kind of like commit. I get the grid out of edit mode, and I go off and bind that thing. And finally, the submit click button is actually kind of interesting too. I get the XML data document back out of the application state, get a data document navigator on top of that, and that's again that XML navigator object I was talking about that plugs into XSL. I get that XSL transform object. I create a writer that will write to a new file I call ponew.xml. I load the transform itself, and then I fire off that transform, giving it the writer. So let's see what all that looks like. By the way, I'll just show you, I've showed you the PO purchase order file already a couple of times, but I'll show you the transform. This is a really pretty brute simple transform. I match the order items, and every one of those items that I find, I fish out the line attribute. I create an attribute in the XML for it, off this order item tag that I've created. And for every one of these other attributes, part number, quantity, and unit price, I actually create an element. So this is a very easy way of transforming the part of the document that I care about, shipping it to the next module in the order processing chain in a typical website. So finally, let's look at what this all looks like. I'm going to edit this thing. Say I'm going to increase the unit price. Before I do that, actually, I'm going to fire off the transform just to show you what the output looks like. This thing is a different format than the XML that came in. That's what my XSL transform did. Now, the actual price on order item 1 is 30. Now, if this doesn't work, I have to drink 10 beers today. I'm going to change this to 40. Click Update. Now you can see that the thing is showing 40 right now, the unit price. I click Transform again. I'm going to actually close this file so that it refreshes when I load. Output of Transform. And here you go, the price is 40. So I have, yeah! Thank you, thank you. So I have two different views on this document. A relational view that plugs into that entire stack of relational services, and an XML view that plugs into that entire stack of XML services, namely that XSL transform. This is actually one of the key innovations that we feel like we've made in the programming model. We hope you like it. We really encourage you to play around with that. So I have a couple more things that I want to talk about before we adjourn here. With all these new objects, you have a lot of different choices of what you want to do and what you can do in the system. So I'm going to give you a little roadmap for what objects to use when. For data consumers that have existing ADO applications, or if you really need that very same semantic that you're used to when you're programming against ADO, say, go use COM interop. We have great facilities inside of the system, the .NET framework, do complete interoperability with old COM objects. In the CD that you get, all you have to do is what you call TLB imp, which imports a type library, and that will expose ADO as a set of managed classes for you. They're really simple wrappers on top of ADO. So again, all of your investment is completely maintained. Yeah. For streaming scenarios, if you're writing new code that wants to take advantage of all the new services we give you, we recommend using managed providers. If I'm doing DML, if I'm doing store procedure execution, doing singleton selects, I don't need that big data set thing. I'm not using, sorting one row table is going to give me a run row table. It's not really all that useful. I can instead use a data reader to get back that singleton query result. Or if I'm just iterating over data very quick and dirty, and I really have performance in mind, again, I would use that data reader, forward-only, read-only object to interact with my data store. If you have caching scenarios, you want to use the data set. You have things that you need to iterate more than once over. You want to do interesting reports. You want very rich manipulation on a form. You want to use the data set. If you're a data provider, in the past, if you just had some comma-delimited file to expose, we told you go write an OLADB provider, or actually go write an OSP, an OLADB simple provider. That's no longer really necessary. Today's comma-delimited format is XML. Just go expose your data as XML. It's very simple to do, and you can plug into our entire framework very easily that way. If you want to expose a store, you actually have some functionality on top of a store that you want to expose to people, we go and tell you, go write an OLADB provider. That gives you the most general mechanism to expose your data. You can wire in not only to the managed world, the .NET framework world, but also into all these very important OLADB consumers that are out there. I've listed 3 of them here on this slide, and they're just only for SQL Server. The distributed query processor, the replication engine, and the data transformation services. And finally, if you have a legacy wire format, like, for example, SQLNet, that you want to expose all the data up through the managed stack, but not go through all these layers in between, we tell you go write a managed provider, and we'll help you do that through that SDK. For XML consumers, if you want to interoperate with today's MS-XML code, just use XML. Anything that MS-XML emits is XML. We can read it. Anything we emit is XML. MS-XML can read it. For streaming scenarios, if you want to wire into the new platform, you want to use that XML reader. For caching scenarios, for example, if you want to materialize all the document into memory, like as in XSLT scenarios, you want to use that XML document. And finally, for crossover consumers, where you, for example, when you're going against SQL Server 2000 that's returning you very relational structured XML, you want to use the data set when it's totally relational. Don't care about the actual structure of the document. Or, if I do care about the structure, I have annotations on that document, I use the XML data document, which is the perfect object, my favorite object, the perfect object for programming against an XML document that has a relational subset. And I hope that was apparent from the demo. And finally, again, those 5 things I want you to take out. Natural evolution, disconnected, XML to the core, one unified architecture, core part of the .NET framework. Yeah, baby. Thank you. And finally, some related sessions that you might want to attend are the following. Mike Pizzo has been here 13 years at Microsoft. He's gone through every single data access technology known to man and has been responsible for most of them. He and Tom Kaiser, who is one of the architects of the data set, are going to give the Using ADO talk right after this session. Using XML Framework, given by Chris Lovett on Friday, is a great talk if you want to know more about the actual details of the XML framework. William Adams, our dev manager, really funny guy, is going to give an XML and action talk that will actually show you real code, real scenarios. Very cool talk. Mike is also going to give an ASP Plus talk for how to integrate data and XML into your applications. And finally, Sean Drain from the Visual Studio team is going to show you how to tie it all in together using Visual Studio. And of course, other web data talks that you might be interested in are the MSXML 3.0 talk that Charlie Heineman is giving and the SQL 2000 talk that Rich Rollman is giving. Now, I'm out of time here, so I'm going to take questions offline here, right over here in this section if you have any. Thanks a lot, guys.
So